Well, welcome everyone. My name is Tom Mullaney. I'm a professor of history here at Stanford. I've been on the faculty now for 20 years next year, and it's an honor to serve as director of Silicon, which, as many of you know, because we've been in contact about this, is a Stanford presidential initiative that's dedicated to advancing digital inclusion in the 21st century. In short, the goal is that for the 7,000 living languages, 7,000 plus living languages on Earth, our goal is that everyone can enjoy the digital age they want on their terms, regardless of the language one speaks. So today I can't even begin to explain how exciting this is. This is our very first Silicon demo day for the Digital Futures Incubator, DeFi. And we're joined by an absolutely stellar group of Stanford students, along with two brilliant high school interns as part of our Silicon High School Internship Program. If you know any high schoolers out there that might be interested in joining us, please let's connect afterwards. And they've spent the past 9 weeks out of 10, next week is the end of the internship, 40 hours a week building what we refer to internally as the Silicon App ecosystem. So many of you saw this list, and we're going to be diving into this over the day. Now, before we dive in, there are some acknowledgements and thanks that we want to give. I am going to be brief. I could take up 20 minutes thanking all the supporters that Silicon has, but I'm going to be a bit telegraphic about that. I would be remiss if I didn't begin, however, thanking Stanford President Jonathan Levin, along with Humanities and Sciences Dean Deborah Satz and Associate Dean Gabriela Safran. They were really with us at the very, very beginning, and we are so grateful for their partnership. Another group that we hold very, very dear in our heart is the Department of History that has served as home base administratively for Silicon at its inception, along with the Department of English, DLCL, Stanford Global Studies for making possible our UNESCO internship, and Unicode for making possible the internship that we're discussing today. So thank you, Mark, Taral, Stephen, Conrad, the entire DDL, Digitally Disadvantaged Language Subcommittee, and the list goes on. We want to also thank Uliza, our partners in South Africa, who've been absolutely amazing in this journey together, and a number of very generous private donors, some of whom are joining us today. You know who you are. We are so very grateful, and we want to show you today just how hard we are working to put all of your support to the maximum effect possible. Without all of you and many more that we'll be writing to separately offline, none of this is possible without you. So I want to set the stage before I turn it over to my brilliant colleagues, just with 4 numbers. 7,000, 98%, 5, and 1,300. What do these numbers mean? Well, one of them you've heard. There are an estimated 7,000 plus living languages on planet Earth. Actually, the number by many estimates is higher. According to the Unicode Consortium, which is arguably the single most important institution for getting writing into the digital age, anytime you see writing on any digital device, you have, in large part, Unicode and the amazing folks there to thank for that. They categorize somewhere in the order of 98% of all living languages as digitally disadvantaged. That is, in one way, shape, or form, different severities, unable to take part in the digital age on their own terms just because of the language that is being spoken. Now, number 5, what does 5 mean here? Well, there are many ways to calculate and estimate how quickly we as a global human society achieving digital equity. One of them that we're going to be talking about a lot is the Unicode CLDR. Don't worry if you've never heard of that. It's an immense internationalization library that makes it possible for your phone and your digital devices to sort of speak your language. And historically, our colleagues have analyzed that about 5 languages on average since the inception of CLDR have been onboarded on an annual basis. Amazing work, a global volunteer force. And at the same time, and even Unicode has been wonderfully sort of committed to this as well. If we follow this logic of 5 languages per year, then it will take 1,300 years to reach full global equity in the digital age, which of course we don't have time for because language extinction and various forces of homogenization in the linguistic sphere are at work. And if we don't change business as usual, then language extinction, quite unfortunately, will take care of the problem for everyone. And that's, of course, not what we want. So as we look forward, what we're trying to think of in Silicon is, can we move from a framework of roughly 5 languages onboarded into the digital realm each year to 150, and maybe even as high as 500? This may be ambitious, but I will remind you that this is the International Decade of Indigenous Languages, mounted by UNESCO, and they too have set forth an ambitious 10-year goal, which is already underway, to try to address global digital equality. So we are quite bluntly talking about a moonshot goal here of rethinking how it quickly, at what pace, at what scale, we try to undertake digital equality in the 21st century, because we do not have 1,300 years to spare. In this discussion, there'll be 2 parts. Part 1, you can think of as the Silicon app pipeline, and this is a subset of those that we'll be demoing today. In a nutshell, over the past year, with the support of many of the very generous private donors here, along with a Stanford University Propel grant, we were able to raise approximately $150,000 in support just of the build out of Unicode CLDR for languages that are not yet in CLDR. We've been partnering with our colleagues in ULISA and many others, working with qualified translators, working with language communities. And as we speak, in fact, we're starting to receive the language translations for the first 3 levels, core, basic, and moderate, of this critically important internationalization library known as CLDR. But there's a problem. Silicon, just like every one of the other organizations that deals in the realm of digital equality, is a very lean organization. Our brilliant colleague, Audrey Gao, who all of you know and admire as much as we do inside of Silicon, is our one full-time staff member, and everyone, very similar to other organizations, are doing this as part of a larger set of responsibilities. So there's a bottleneck. So the very first task that we put out in this incubator to our brilliant team here is, how in the world are we going to deal with the fact that about 50 translations are going to be coming into our inbox at Silicon very soon? The first part of this discussion is how this brilliant team solved this puzzle, and quite simply put, will enable us to handle practically any level of arriving translations from this point on, whether 10 a year, 50 a year, 500 a year. So this is Lexray, MockBlock, Carwash, and Quizás, which you'll be hearing about very soon. Now, the second part of this, before we dive into part 1 with our colleague Daniel Argento, Lexray, will be the larger Silicon app ecosystem, but we'll get to that very soon. So first, let me turn it over to my brilliant colleague, Daniel Argento, who will lead us through the first app in this app pipeline known as Lexray. Daniel.
Thank you, Tom, for the introduction. I want you to imagine this. You're on your phone or your laptop today, and you see the date August 25th written on your home screen. But now imagine that you're not in the US and that your native language isn't English. It's actually Spanish. That same date isn't August 25th. It's actually now 25 de agosto. Different order and different words. The way that computers know how to handle this cross-linguistic mapping isn't magic. It's actually thanks to Unicode's huge database, as Tom referenced, called the CLDR, or Common Locale Data Repository. It tells your devices how to display dates, times, and words in hundreds of different languages and locales. So without it, our digital world would basically only function in a few of the dominant languages. But here's the problem. Adding new languages to the CLDR is not as easy as it could be. You can't really just provide the translation. You also need to know how the translation is structured, namely the relative ordering of months, days, and years within the expression. So, for example, an expression of the form 25 de agosto would be entered as a single D followed by the word day in single quotes and 4 capital M's. So if that even sounds a bit confusing, that's exactly the point. For many language speakers, this is one barrier that hinders their ability to contribute data. But that's where my program Lexray comes in. The idea is simple, that instead of requiring contributors to learn how to reformat their translations into complex and somewhat esoteric formatting codes, Lexray does it for them. A speaker just provides the natural translation like 25 de agosto in Spanish, and Lexray automatically converts that into skeleton code that CLDR can understand. And it doesn't just do this one example at a time. It's built with the ability to process batch data, allowing entire sets of translations for a new language to be handled at a single time. This turns what was once a painstaking and manual task into something that is now streamlined and very scalable. The cool thing too is that this tool isn't meant to live in isolation. It will later be embedded into CLDR Academy, which is an online one-stop shop for learning best practices for taking part in digital inclusion efforts and contributing data to the CLDR. So taking a step back, why does this all matter? Well, importantly, it opens the door. So suddenly so many more people can contribute language data without needing to set aside time to learn how to properly format these translations. And community members, not just those internal to Unicode, can contribute their knowledge directly. The impact goes beyond just efficiency and improved accuracy of data, because really now every time a new language is entered into the CLDR, it means that speakers of that language can see the digital world in their own terms and not forced into someone else's. This is about ensuring that the internet reflects the richness of human language, the 7,000, as Tom mentioned, not just the convenience of a very few. So LexRay ensures our data is correctly formatted for the global standard. But before we can incorporate that into Unicode's international library, we need to triple check its accuracy. That's where my colleague Neve Sidani's MockBlock program comes in.
Thanks so much for the pass off, Daniel. Hey y'all, hope you're doing fantastic. I'm Neve. And before we, get into this, we want to talk about the last project, LexRay. Once we get the output from LexRay, we still need to quality control it before it can be incorporated into Unicode CLDR. So what's the best way of doing that? Visually. As many of you may or may not know, Silicon relies on language contributors to verify accuracy in translation and common data types like months, days, etc. However, this verification process can be really tacky. My project aims to simplify the flow from Silicon to the contributor, providing real-world applications of their language to better explain the context in which their contributions are being used. Here are some of our current barriers. They'll help contextualize things. First, there aren't many tools to automate the creation of UI/UX components. Second, contributors should want to help out, so how might we build an attractive and efficient language contribution initiative? Third, scaling and integrating these projects within Silicon requires lots of steps and iteration. And fourth, how can those who want to develop for disadvantaged languages do so, given that there are little to no design standards for these communities? I want to start by introducing MockBlock. This is an application that takes language data provided by translators and contributors and instantly turns them into real-world, intuitive app mockups and components, nicknamed blocks, so they can see their translation work in context, spot mistakes, and fix them in real time. They don't need to know data science or have any linguistic skills. I built a template system containing over 130 application mockups that you can see on the top left. They take in a sample translated language data set and produce UI/UX components that contextualize how those words may be used. Let's say we want to double check that we have the correct abbreviations of months of the year, like Jan for January, or days of the week, like S for Sunday. Instead of presenting a list in a spreadsheet, at Silicon, we want to present full UI/UX mockups, a calendar UI showing abbreviated months, for example, or perhaps a health tracker app showing abbreviated days of the week. This can then be sent back to the contributor for validation, addressing the lack of UI/UX components for disadvantaged communities and the need for reform in our language contribution system. At Silicon, context is everything. And what better way to embody that than to have real-time examples of how contributor input is used? Now, my second project aims to address the lack of design standards for disadvantaged languages. We may know what a calendar looks like in English because there are thousands of applications that share similar design fundamentals. But this isn't always true, especially when considering communities that aren't typically designed for due to a smaller consumer base. As part of MockBlock, we designed a screenshot library highlighting designs that include disadvantaged languages. Think Pinterest, but for designers, focused on disadvantaged languages. In the UI/UX community, it is commonly known that designers never design in isolation, always drawing inspiration from art, other applications, etc. Similarly, designers working in digitally disadvantaged languages shouldn't have to design in isolation either. MockBlock acts as a sort of design standard or handbook that designers can look at when drafting mockups for systems that they may be unfamiliar with. Users can upload screenshot blocks and application flows, create collections and sort their favorite screenshots, search by CLDR types, language metadata, UI/UX component, and many other relevant filters. So how do these two projects connect, the template system and the application? Our goal for now is to have these initial design mockups from the Figma template system form the foundation for the MockBlock screenshot database on launch. Until user contributions roll in, we will use validated UI/UX components from the community as a working ground. With time, we'll have our UI/UX templates be solely for simplifying the data collection process from language contributors and have MockBlock be its own entity, allowing users to design for disadvantaged languages effectively. Once we confirm and fix the original language data, Silicon can quickly update the CLDR skeletons and patterns first identified by Lexray. Then we're ready for the next step, helping communities get started on creating a keyboard for their language. That's where Aaron Dye's Carwash and Kizas come in.
Thank you, Neve, and I'm excited to share with you Carwash and Kizas. Every day we type on our phones and computers without a second thought, but what if your language wasn't there? For thousands of languages, this is reality, and for these languages, the journey to digital text is blocked by two fundamental barriers. The first step is defining its characters for the language, the letters, syllables, or alphabets from which it is built. So our first tool, Carwash, automates this. It receives any language text, like from Lexray, washes it, and then generates a high-confidence character set, presented back to the user in a clean, easy quality control interface. An example is this picture right on the right. And it works. We tested Carwash on 18 diverse languages, from Latin to Arabic scripts. The results were remarkable. Our tool successfully identified 99% of the main letters and 98% of the index letters documented in Unicode's CLDR database. Successfully, we turned this process that could take months into minutes. But a character list is just the beginning. The next intimidating challenge is, how do we design a keyboard for this? Where do we even start? This is where the second stage of our pipeline, Kizas, comes in, named partially after the beloved song by Cuban songwriter Osvaldo Farras. Kizas takes a confirmed character set from Carwash against our database of over 200 Microsoft keyboard layouts from around the globe, and analyzes every keyboard to find the top 10 best matches for the new language, ranking them on two key matrix: coverage, which tells us how many of the language's characters does this keyboard provide, and overlap, which measures how much of the keyboard is useful. Our analysis of 12 Latin-based languages showed that the top-ranked keyboard on average provides 84% of coverage right out of the box. This completely eliminates the blank page problem, giving communities a data-driven, practical starting point. But it doesn't really stop here. To make it truly useful, we created a 3D visualizer built on top of the keyboard simulator, an open-source 3D visualizer created by Carson Britt and contributors on GitHub. Here's how it works. For example, Kizas can help us output the top 10 keyboard files for the Bambara language. We simply paste these top 10 keyboard files into the visualizer, like this screenshot on the page. And instantly, the tool creates a curated drop-down menu containing only these top 10 keyboards, perfectly ranked. The default library is gone, replaced by a focused actionable list. A user can now instantly visualize the top 1 recommended keyboard, and they can see the layout, access character placement, and get a real feel of how it works. And with a single click in the dropdown, they can switch to the second best option, third best option, etc., allowing for a direct comparison. But what if a layout is close but not perfect? How do we close the final 16% gap? Watch this. We put the power to customize directly into the user's hand. A user can now edit the keyboard's code right in the browser to change what's on each key. And as they make a change, the 3D model updates instantly, like the two pictures on the right that changes a B to an A. This transforms rapid prototyping into an intuitive and immediate process. And in addition to manipulating and visualizing data within Kizas, users can easily copy, paste, and export their results, enabling integration with Keyman and other widely adopted platforms. This compatibility ensures that the work done in Kizas is not siloed, but instead feeds into the existing pipelines and tools that communities are already using for script, keyboard, and other localization projects. So now this is a complete end-to-end pipeline. We take a language's raw text and deliver a clean alphabet and a data-driven visual path to a working keyboard. We are replacing a slow, manual, and expensive process with one that is fast, automated, and empowering. So a language community doesn't need to wait for institutional funding or outside experts to begin its digital journey. We give them the tools to directly start themselves.
Thank you so much. So now we're going to transition into part 2, which is effectively the broader ecosystem. So these 4 tools, Lexray, Machblock, Carwash, and Quizás, effectively give Silicon and our partners the tools that we need to handle digital inclusion at scale for this initial set of language materials that I've identified before that are coming in. But Silicon is thinking at an even broader level. What tools and processes can we develop to further support an even more robust, sustainable, and longer-term digital inclusion workflow? With this, we're going to transition to the second part of today's demo day, where we introduce the other parts of this broader app ecosystem. Home screen, Milkshake, Silboat, SteamType, IU.io, and Qmoji. Let me turn this over to the amazing team at Home Screen, Alyssa Huang, Christian Roy, and Tyler Abernath.
Thank you so much for that introduction, Tom, and we are so excited to share Home Screen with you. Home Screen is a user-friendly portal that's designed to make language data contribution simple, engaging, and efficient. Traditionally, language data collection through the CLDR survey tool is a lengthy and highly technical process with a UI that can be a little difficult to navigate for your average user. Sometimes those who are willing to contribute their language data might be met with a complicated screen and input method. They may feel a little overwhelmed and confused at where to start. Home Screen's goal is to work side by side with the CLDR and the survey tool to break down many of these barriers to entry. Home Screen consists of story-like levels, each with a few short surveys. Every survey is paired with a quick 20-second context video that introduces the CLDR relevant data types through a visual and auditory aid. These engaging short-form videos use storytelling to make the content fun, conversational, and easy for contributors to grasp. For example, a video might use a trip to the movies and the movie runtime to introduce the concepts of hours, minutes, and seconds.
Thank you, Tyler. So we want to emphasize that Home Screen is still in beta, and one of its main goals that we continue to build towards is efficiency. Our research shows that many data points we collect are strongly correlated. What this means is that we can often infer one answer from the other. Instead of asking contributors to repeat their answers, these correlations help Home Screen reduce redundancy, while still giving people the option to make edits if needed. With research-backed logic branching, contributors are only asked questions that are truly necessary, keeping the process fast, accurate, and efficient at every step. Our approach minimizes the time and effort required, while maximizing both intuitiveness and accuracy. Home Screen provides a smooth, supportive user experience that encourages a wider reach of people to contribute their valuable language data.
Thank you, Alyssa. And since Home Screen also connects directly to the other projects you've already heard about, these gains ripple outward. For example, language data collected in Home Screen can be structured by Lexray, visualized in real mockups through Machblock, and used by Carwash and Quizás to identify character sets and suggest keyboard layouts. In other words, efficiency at the survey stage multiplies across the entire data pipeline, making every tool stronger. Currently in the beta stage, Home Screen is available in English. In the future stages, the microsurveys will be translated into French, Spanish, and Portuguese, followed by other common languages to make it as accessible as possible. The videos, the multiple choice, and the text explanations, as well as the survey language will all be translated. Beyond bringing more languages into digital spheres, one of our driving principles is for everyone to feel welcome in the online world. We strive for everyone's home screen to show the time, date, and text in a language and format that feels familiar to them. The home screen name embodies this goal, and through its principles of efficiency, accessibility, and friendly user experience, aims to help all language speakers feel at home. Home screen is one way of making language data contribution more accessible. Our next project seeks to reduce contributor labor even more. Next up is Samantha Leventis and her project Milkshake.
Hello, everybody. I'm going to introduce to you Milkshake. So, Milkshake essentially takes a second look at the large publicly available translation data, for example, Meta's No Language Left Behind, Masakane, and more. While these corpora were originally created for machine translation, they actually also contain a lot of hidden gems, namely CLDR relevant data that can be identified, extracted, and stored. After all, machine translation is most useful when it's supported by strong fundamentals and foundational tools. So Milkshake is a custom NLP extraction tool that finds those gems and presents them in a simple quality control interface like MockBlock, which we discussed earlier, so contributors can quickly confirm what's accurate. So it doesn't build a full data set on its own, but it gets us much of the way there. It milks every bit of data, so to speak. Essentially, by reimagining and repurposing existing data, we shake out every hidden insight, collecting every valuable crumb. So let's take a look at Milkshake in action. When users arrive, they're greeted with this clean, intuitive interface where they can select their target language as well as the elements they want to extract, such as, months, days of the week, or time-related vocabulary. For added flexibility, there's actually also an other option, which allows users to define custom regex or vocabulary patterns to capture, any vocabulary that they choose. But after selecting the script type and uploading their parallel files, Milkshake takes over, running the data through a powerful pipeline of alignment and extraction tools. The output is a ready-to-use file, CSV or Excel, with each term and its most likely translation, the frequency of that most likely translation, and some alternative translation variants. And these variants can be based on spelling, plurals, or anything of the like. So the CSV or Excel file can be downloaded, exported, and utilized to support research, teaching, or just other further linguistic analysis. The contents will also be piped into MockBlock on the right here, which provides intuitive visualizations, allowing members of the language communities to validate the data and contribute corrections or enhancements. So Milkshake is actually already showing some great promise, outperforming other models on core tasks. For instance, it achieved 150% of the accuracy of Meta's No Language Left Behind translation model. So we're really confident that in the hands of a native speaker, Milkshake will deliver highly accurate results faster than ever. As we move forward, we really envision Milkshake growing beyond Silicon itself, partnering with communities, nonprofits, and other organizations to help them unlock the value of other still open data sets that they otherwise couldn't process. Thank you.
Thanks so much for that amazing presentation, Samantha. So on that note of unlocking value, one of the partnerships that Silicon is exploring facilitating is that between community partner organizations, research labs, nonprofits, and students and academic institutions. The Silicon app ecosystem, sorry, you can go back to the previous slide. The Silicon app ecosystem has been built to dramatically scale up the building of core language tools, from internationalization libraries to keyboard design and even typeface development. But there are other foundational tools that speakers of highly resourced languages take for granted. So think of spell checkers and grammar checkers, the little red squiggles under a misspelled word, or the suggestion to change effect with an E to effect with an A. For digitally disadvantaged languages, these tools are missing, not because they're impossible to build, but because they require more data and time and intentional engagement. That's where Silboat comes in. Silboat is a program designed to tackle these slightly higher order language tools, including spell checkers, grammar checkers, morphological analyzers, automatic speech recognition, and more, and to connect these projects with university ecosystems at Stanford and beyond. By turning these real-world language challenges into ready-to-deploy student projects, Silboat taps into the incredible brain trust of computer science, linguistics, design, and engineering talent across universities. It's a model where everyone benefits. Communities receive meaningful technical support for building critical digital tools. Students get to apply their skills to meet impactful real-world problems while earning academic credit, and faculty gain access to high-quality optional project opportunities that they can integrate into coursework, particularly for capstone or final projects. We've already started some serious dialogues with partners in Brazil and Kazakhstan, and we are just getting started. So do you have a project? Do you teach a class? Let Silboat do the work. Silboat targets coursework at the university level, but we aren't stopping there. We're also introducing language projects to younger students, and I'll pass the mic to Tom, who will tell you more about this next initiative.
Thank you so much, Tyler. So at Silicon, as we've noted, the focus has been on the really foundational aspects of language. We care a lot about AI and large language models and ChatGPT and et cetera, but what we really care about are the circuitry, the rebar of language that is so taken for granted among speakers of highly resourced languages, but is still awaiting for many thousands and many languages and many billions of language speakers. So keyboards, internationalization libraries, fonts, etc. One aspect of this, of course, are typefaces. You cannot include a language you cannot see. Now, at Silicon more broadly, we have built out and invested countless hours and support to the two programs you see in the middle, the Knuth Bigelow Incubator, named after the legendary Donald Knuth and Charles Bigelow. We just had our inaugural cohort somewhere in the audience of early career type designers who are not quite at the level of applying to perhaps a University of Reading or a KBK or a graduate program, but are very, very far along in many cases in their careers. And then to the far right, the Dr. Chen Ye Practitioner Program, which is now entering its second year, where we directly fund advanced mid-career type designers with a focus on typefaces for under-resourced or digitally disadvantaged languages. But we don't want to stop there. On the far left, you see K through 12, and that's what we mean. Kindergarten through 12th grade, a program known as STEAM Type, which is committed to globalizing type design education, especially for under-resourced or underrepresented languages, all the way down to the kindergarten level and through high school. So a full pipeline, so to speak, that feeds into the infrastructure of type design education that is already incredibly robust all around the world. Now, many of you, by the way, just a shout out to the Knuth Bigelow Incubator cohort. We are so unbelievably proud of the work that you have done. This is just a small subset. We had type designers from 30 countries all around the world, and they just did an absolutely stellar job. Now, for the younger folks, what the goal of this is to think very, very far ahead in changing the demographics of the pipeline of type designers. And we want to start early. So through a series of targeted assemblies, school visits, whether in person or virtual, these could be 30 or 45 minutes, a STEAM type representative goes into a classroom all the way down to kindergarten to 12th grade and undertakes a very kind of lightweight introduction to type design. All they do, they don't need newfangled technology or computers. They can go in with a variety of printouts and handouts similar to what you see here by the open source program Calligrapher, in which students are invited to simply draw out by markers, or you can build in a variety of ways, a alphabet, a character set, a syllabary. And this can be done for any writing system that is in Unicode. So there are tens of thousands of sort of options. From this, through a very simple procedure, one then ingests this into programs like Calligrapher, but there are others that turn hand-drawn letters and symbols into a fully functioning font that you can install on your program and then start typing on Microsoft Word or other applications. Now, for the type designers in the audience, you might be reeling in horror at the low quality of this. This is a first grader. This is a second grader. We don't care about quality. We care about infecting them with a joy and a love for the very idea of design itself. And on top of that, we get to sort of spark that curiosity in the languages that they may speak at home that is not the dominant language of their classroom. So we're starting to collaborate right now with the Palo Alto School District, with the Palo Alto Chamber of Commerce, and the Northern California school system more broadly as pilot plans. Then we'll be expanding to the broader US and globally, purely for the purpose of getting young people involved in type design in a multilingual way. And we don't have to stop there. At the K for kindergarten, first grade, second grade, third grade levels, this is simply an act of literacy, of drawing, and a little bit about connecting young people, grandchildren with maybe grandparents or other guardians who may speak a mother tongue that the child does not. And this is a very low barrier entry way for a kind of cross-cultural interaction conversation within a family itself. But then for the middle levels, fifth grade and up, we can actually introduce open source type design software, bringing this hand-drawn font into an actual font editor and integrate that into, say, middle school education, where many, many schools out there are very, very interested in what's known as STEAM education: science, technology, engineering, arts, and medicine. So STEAM, design, etc. This takes this then to the next level. And of course, for many, and I know that there are some amazing people in the audience who know this well, by the time we get to 9th, 10th, 11th, and 12th grade, we can integrate this into computer science courses. That is Python for type design or creative coding. And so it's in a sense a full stack pipeline, K through 12, that quite literally is a conspiracy, a global conspiracy to promote multilingual type design curiosity and education that then feeds into the kinds of pipelines we've already built in the Knuth Bigelow Incubator and many other programs in the university and high school level worldwide, and then into the very advanced global infrastructure of MFA programs, PhD programs, MA programs in type design. So we are thinking this is probably the longest horizon, longest term investment of Silicon, but one that we are very, very excited about. Now, as we transition to the next one, before we introduce to our colleagues, Matthias and to Diana, who's going to close us out in this demo day, the basic fact of the matter is there are many, many language communities that even if one were to put the survey tool in front of one or home screen in front of one, are in fact not in an ideal position to begin contributing data. This is not because of a lack of interest in fashioning a digital age that serves them, but in many cases, because of historical legacies of colonialism, legacies of certain global inequalities, quite literally, the terminology that they might contribute hasn't been stabilized or it hasn't been translated. And so the final two projects are also long-term parts of the Silicon app ecosystem that are all about how we can involve communities in a deliberative democratic process of stabilizing certain terminology in order then to be in a position to contribute it to open source data sets like CLDR and others. I turn it over to my colleague, Matthias, who's going to walk us through IU.io.
Thank you very much, Tom. Today, I'm very excited to introduce you to all to IU.io. What if every community, no matter how small or historically excluded, had the tools to shape how their languages lives or reads in the digital world? Another question, how do communities turn abstract ideas and highly technical concepts into a unified languages that speak across different apps, tools, and platforms? In this case, IU.io, Community Decided Technical Terminology, tackles this question head-on by designing a framework that empowers post-colonial languages communities to democratically agree on a stable terminology translations. Our decision to name the project was inspired by the Quechua word Ayu, which signifies community, group, and family, and to honor the work, research, and interviews I conducted in Quechua communities all around Peru in South America. This is a very human-centered process. Through historical analysis from Meiji Japan to Qin China, in-depth interviews with grassroots leaders across Africa, South Asia, and rural Peru, and the development of visual workflow diagrams, this project offers critical insights into how communities navigate these very complex processes on agreeing on technical terminology. By conducting on-site fieldwork, joining focus groups via WhatsApp, Facebook groups, and other platforms, attending community gatherings, and writing samples, it helps us understand that the various ways in which collective decisions on terminology are made in these different global communities. As part of the technical data process, I conducted interviews, focus groups, and fieldwork, in this case in the Quechua-speaking communities in Peru, as a baseline to collect and organize different terminology for, in this case, for minerals, rocks, and precious stones, drawing on oral traditions, written sources, and collective community deliberation. This effort produced foundational artifacts such as the first Quechua chemical periodic table of elements and a comprehensive suffix analysis of charts that capture how nuanced meanings are constructed in agglutinative languages. Although developed in Quechua contexts for this case, this methodology provides a ready-to-adapt framework for any global languages around the world to systematically document and agree upon new technical terms through culture-grounded and participatory data practices. These findings contribute significantly to the Unicode CLDR readiness while also laying the groundwork for building multilingual educational curricula, culturally relevant medical and legal translation tools, custom keyboards, and user interfaces that genuinely reflect the lived experiences, knowledge systems, and values of the communities we want to help. As part of that process, it's also my pleasure to turn this over to my colleague Diana, who will be introducing the final part of the Silicon app ecosystem, Kimoji.
Are a powerful way we communicate with each other, helping us express emotions and ideas beyond words. But their meanings aren't always universal, as they can shift depending on language, culture, or even generation. Take the sobbing emoji. Some see it as deep sadness, while others use it to mean uncontrollable laughter. So, how do we capture and understand these differences? The key to language revitalization and engagement in the 21st century is getting young people involved. But here's the problem. Emojis, despite looking so simple, are in fact amongst the hardest components of the Unicode CLDR to translate. Why? Because emojis carry deep cultural associations, meanings that can shift dramatically from one community to another. What's more, emoji live in what's called the modern section of the CLDR, which means that most digitally disadvantaged language communities don't even get the opportunity to translate them into their own languages. This creates a serious gap in representation and digital inclusion. That's where Kimoji comes in. Kimoji is a multiplayer game that turns emoji interpretation into playful collaboration. On the surface, it feels like a lighthearted party game, but underneath, it's a powerful tool. As players describe emojis in their own words, the responses are recorded, building a data set of how different groups interpret meaning. In the process, players aren't just having fun, they're contributing critical linguistic data that supports digital inclusion, while developing a sense of ownership and pride in their languages. Currently, we have 2 board game versions of Kimoji. This first version was inspired by the board game Hues and Cues. In that game, players describe colors and others guess, but they can't use obvious words like red or blue. Now imagine swapping colors for emojis. That's essentially version 1. The board has 416 emojis grouped by themes. Players choose a card, select one emoji from the 4 on that card, and then give 1 to 2 word clue for others to guess. Besides our regular cards, we also have wild cards where players must act out their emoji. That could mean acting out a cyclone or pretending to be a chair, which always leads to funny moments. Now here's version 2, our latest design. This version introduces a dice-based movement system. Players roll and move that many spaces. Depending on where they land, they might get a normal space, an acted out space for emoji charades, a lightning round shortcut, or a swap space where they trade positions with another player. On every turn, the player also flips an emoji card. Then everyone has 20 seconds to write as many descriptive words as they can. At the end, everyone reveals their notes, and any shared words let players move extra spaces forward. This mechanic not only makes the game more interactive, it also captures how different people think about the same emoji in real time. And while not the focus of today's presentation, we also have a preliminary web app and an app workflow in Figma for a future Kimoji mobile app. These digital versions would allow players to engage online, hover over emojis for better viewing, flip cards, and track their points. We're exploring how Kimoji can expand beyond the board and reach more people in a playful, accessible way. So, at its core, Kimoji is about more than just a fun game. By playing, users aren't just laughing with friends, they're actively contributing to Silicon Unicode's mission of building a more digitally inclusive world, one where communities whose languages are often left out can finally see themselves represented online. Kimoji makes that work both engaging and joyful.
Wonderful. Well, let me just say a few closing words, and then we're very excited to open up for questions, and we'll continue these questions offline, no doubt. Silicon stands on the shoulders of Stanford's legacy in innovation and interdisciplinary collaboration. I think you see that just shining through in this incredible group here. The goal here is to unite community engagement, technology, expertise, and an emphasis on equity, with an eye not just on deploying new tools and apps, but on building resilient language community contribution ecosystems that grow with the changing needs and interests of communities who help build them. Today, we've seen tools that work right now to handle the urgent wave of new language data sets that we described that we're on the receiving end of over the course of this summer. Tools that turn these data sets into real world mockups for QC quality control, and then systems to bring in expanded future contributions, as well as long-term investments in the broader digital equality ecosystem itself. The goal is to form a virtuous circle with the output of any one tool contributing and supporting that of another. So after these demos, we want to open up the Q&A right away. We would love your feedback, your ideas, especially if there's any particular tool or tools that gain kind of spark your interest. We'd love to see if you'd like to test it out, take a look at it after the fact. There's going to be plenty of opportunities for follow-up conversations. And we especially welcome advice on connecting with more communities, with investors, potential board members to help these initiatives thrive. So thank you one and all, and thank you to our amazing team here. Let's go ahead and stop share and open this up.